We're back with day 87. Today we're working on revolving regions around the y-axis. So this should come somewhat naturally to you after revolving around the x-axis, but there are a couple of key changes that need to be made to adjust for it. They don't do this all the time on the AP exam, but it can be on there, and it's a place where we can separate ourselves from the rest of the pack. The average student who takes the class struggles with this, so mastering this topic can give you a leg up over other people. So I'm going to start with talking about the region. The region that I'm going to use for my example today is we're going to have y equals x squared over 2 and y equals 2x. So we're taking the region bounded by those two, and we are going to revolve around the y-axis. Whenever you see this, revolve around the y-axis, you need your antennas up. Got to be very careful when you do this. Okay, there's a couple of big changes that are different than revolving around the x-axis. Okay, just like before, we could have a disk method, we could have a washer method. This example is going to be a washer method. So we want to start by getting an idea of the sketch of these two graphs. X squared over 2 is just a parabola. It opens a little bit wider than the parent function of x squared, and y equals 2x is just a line. So when we take a look at this, here's what we have. Here is half x squared and it goes back here, but it's not going to play a role. And here comes y equals 2x. We have intersections here and here. This is not, I did not draw this very well to scale, but it doesn't really matter. Okay, now sometimes on the AP exam they'll tell you those intersection points. Sometimes they won't. So let's get an idea of what those are. It's pretty obvious that 0, 0 is an intersection point, because 0 squared over 2 equals 0, and 2 times 0 equals 0. So this one right here we get to be 0, 0. And how about the other one? Well, we can set the two functions equal to each other to find that second intersection. The first thing I would do to both functions is times by 2 to get rid of the fraction. Right? This could also be written as half x squared, but x squared over 2 means the same thing. When we multiply by 2, we get x squared equals 4x. Again, to solve this, then I want to, it's a quadratic, so I want to set it equal to 0. X squared minus 4x equals 0. Simple factoring out of the x clearly shows us that our two x coordinates of intersection are x equals 0 and x equals 4. Get out of here. X equals 4. Okay, so I know that this is 4 right here. Now, if I asked you to revolve this around the x-axis, you'd have no problem setting this up. You'd just do the integral from 0 to 4, or pi times the integral from 0 to 4 of the top function, so 2x squared minus the bottom function, x squared over 2 squared. Right, and you'd have to fight your way through it, but you can solve it. But what we're doing today is different. We're taking this thing and we're revolving it around the y-axis. Okay? So when we do that, we're going to create, it's kind of hard to draw here. We're going to create washers, but those washers are, perpendicular to the y-axis rather than being perpendicular to the x-axis like we're used to. Okay? So again, we can look at this washer to figure out our big radius and our small radius, just like the washer method around the x-axis. But here comes the fundamental change that's going to be different about this compared to around the x-axis. We're stacking up all of these washers, but we're stacking them up right from down here at the bottom all the way to the top. So instead of integrating left to right like we're used to here, we're going to integrate bottom to top. Because of that, I can't just be satisfied with the x coordinates of those intersection points, right? I know this point right here has an x value of 4. But because I need to know the y, I'm going to integrate from bottom to top, I need to know both of these y coordinates of the intersections. Well, 0, 0 was pretty obvious. It's right there. Okay? To figure out this y coordinate, then, I can plug 4. I should be able to plug it into either equation, right? When I plug 4 in for x here, 2 times 4 equals 8. Or I could plug in 4 up here. 4 squared is 16. 16 divided by 2 is 8. Obviously, since it's an intersection point, you can plug it into either one to get that y coordinate. Okay? So once again, I'm going to have integral of pi big R squared minus little r squared dx. But instead of integrating from the x intersection to the other x intersection, I have to integrate from the y intersection to the y intersection. That's a huge difference, right? So this is going to go from 0 to 8. Okay? So if we're keeping track of differences here, things to remember. Number 1, we integrate from bottom to top. Okay? So these are the y coordinates of intersections. That's the first of 2 big differences. Okay? The other big difference is what is our big R and what is our little r. Okay? We can tell by inspection here that the big radius is going to tie to this function, which is y equals x squared over 2. And the little radius is going to tie to this function, which is y equals 2x. The problem here is that the second thing we need to do is both of these equations have, since we're integrating along the y-axis, we have to solve for x, so our function is in terms of x equals something y. So the second big thing that you have to do, solve your equations for x. That's huge, as well as finding the y coordinates of the intersections. Those are the 2 big differences. It should be intuitive which function is the big radius and which function is the little radius, but you need to solve those equations for x, and oftentimes they've already been solved for you in terms of y. Okay? So what I need to do here is I want to take this function. This is going to tie to my big radius. Keep track of this down here. Okay, I'll find big radius equals. So what I need to do is this function is my big radius, but what I have to do is solve for x. So I'm going to solve for x by multiplying both sides by 2, and then doing the square root. Now when we do the square root, we get a plus or minus square root. Because we're in quadrant 1, we're just going to be focusing on the positive square root. Okay? So the big radius, the function that we're going to integrate, is root 2y. The little radius, then, I need to solve this function for x. Well, that's a pretty easy one-stepper. I get x equals half y. I divide both sides by 2. So my little radius is equal to half y. So the way I remember it is when we're revolving around the y-axis, make sure your big R and your little r are in terms of y, right? Solve for x, so your function is in terms of y. Okay? Putting this all together now, let's actually solve this one out. The volume of this region, which is going to be fundamentally different than the region that was revolved around the x-axis, our volume is going to be pi. Integral from bottom to top. The bottom was 0, the top was 8. It's not 0 to 4, it's 0 to 8. Okay? Big radius squared. The big radius was root 2y, and I have to square that, minus the little radius squared. The little radius was half y, and I have to square that. And now my integral, instead of being in terms of dx, I'm integrating with respect to the variable y. So when we revolve around the y-axis, our integral should say dy at the end. When we revolve around the x-axis or any other horizontal axis, it should be in terms of dx. Okay, solving this thing out quickly. I got 3 minutes. Let's solve it. I want to simplify this thing before I do it. Root 2y squared is 2y. And then half y quantity squared would be 1/4 y squared. We're at least going to get this thing set up. Now I'm ready to bump and divide. So this will be y squared minus, I got to bump this up to 3 and divide by 3. 1/4 divided by 3 is 1/12. Oops. Sorry, this should be in brackets. Zero to 8. Then I got to plug in. So my volume is going to be pi times 8 squared minus 1/12 of 8 cubed minus 0. Okay, 8 squared is 64. I'll just, I'm out of time. I'll solve it out to a final answer and post that in the comments here. But this is our answer right here. Okay? So, the 2 key takeaways here. Number 1, we got to do bottom to top. We have to integrate bottom to top, make sure those are y coordinates. And then you need to solve both equations for x. Okay? Still find your big R, still find your little r. We're still squaring and subtracting those. That's it for today. Thanks for doing 2 videos for 1 class. I'll see you guys on tomorrow, Wednesday. See ya. Bye. 2 chains. Bye.